So, the next algebraic trick I want to talk about is polynomial long division. So, it's very useful for when you have the degree of the polynomial in the denominator being less than the degree in the top. So, if you see a fraction where the top degree is higher than the bottom degree, you can actually use long division to help you do that. So, for example, so this is just a really cool case where if it's possible, so that's why it says if you can, you might be able to make your division really easy. Because remember, we learned in junior school, I'm not sure, I learned this in like year 8 or year 9, but I'm not sure how, because I know different schools teach different content, I think, in the junior schools, so I'm not sure if you've ever done it, but remember that you can factorize x cubed minus 1 as x minus 1, x squared plus x plus 1. Even if you didn't do this in junior school, you would have done this in year 12 extension 2 when you did complex numbers, because you would have looked at a lot of divisions like that. So it's not just x cubed minus 1. Remember, you learned x power n minus 1 is equal to x minus 1, x and minus 1. Like, yeah, you remember that. So you learned this already in the course. But yeah, for x cubed here, there's also an x cubed plus 1 factorization where it was x plus 1 x squared minus x plus 1. So that was another thing that we learned at the same time in like year 9 when we did that. It's called the sum and difference of two cubes. Okay. But anyway, here, because we recognize there's an x squared plus x plus 1, what you could have done here is you could have just subtracted a 1 and then added a 1, so that when you factorize the top as this thing, it will cancel out with the x squared plus x plus 1 in the bottom to just give you x minus 1. So you could have done that. And then afterwards with this fraction, you could just complete the square like what we did. And then you can use the inverse tan result in order to get the final answer, which would have been this result. So instead of using reverse chain rule, you could have done long division here, and that would have been fine. But you could have also, if you didn't want to do that, you could just use direct long division. So if the degree of the polynomial is in the top is more than in the bottom, or if it's in the bottom less than the top, same thing of saying the same. Two different ways of saying the same thing. You could have just literally done long division. Like, you want to divide x cubed with x squared plus x plus 1. Well, we want to, this is the same thing as plus 0x squared plus 0x plus 1. So we want to multiply this with x. So we get x cubed plus x squared plus x will be minus x squared minus x. So we'll get minus 1. So this will be minus x squared minus x. So minus x squared minus x minus 1. So this will be minus 1. So yeah, this would mean that you could say that x minus that x cubed over x squared plus x plus 1 is going to be, remember we got your we got the quotient, so x minus 1. We got the remainder, minus 1, over the divisor, so x squared plus x plus 1. So you didn't even need to recognize this using the algebra stuff. You could have just directly did long division on this, and it would have worked out when you wrote it as in terms of the when you divide this with that, you get the quotient with the remainder over the divisor. Remember that form where, when you learn about this in polynomials. Okay, so you could have rewrote that in terms of this, and then you could have directly integrated this using what we did here. Okay,